Day 824 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3310, remove methods from project. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are maintaining a project that has n methods numbered from 0 to n minus 1. You are given two integers n and k in a 2D integer array invocations where invocations of I is equal to AI bi indicates that method AI invokes bi. There's a known bug in method k. Method k, along with any method invoked by it, either directly or indirectly, are considered suspicious and we aim to remove them. A group of methods can only be removed if no method outside the group invokes any method within it. Return an array containing all the remaining methods after removing all the suspicious methods. You may return the answer in any order. If it is not possible to remove all the suspicious methods, none should be removed. All right, y'all, so that seems a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So, in example 1, our input n equals 4, k equals 1, invocations equals an array of integers 1, 2, next array 0, 1, last array 3, 2. Output is an array of integers 0, 1, 2, 3. So, let's see how we got this output from this input. So, we have this picture right here that they gave us. So this lets us know 1 points to 2, boom. 0 points to 1, boom. And 3 points to 2, boom. Now K lets us know that 1 is suspicious, boom, right? And since 1 is suspicious and 1 points to 2, that means 1 and 2 are suspicious. Now 2 is suspicious as well because it's invoked by 1. It says method K along with any method invoked by it either directly or indirectly are considered suspicious. So since 1, you see how this arrow points to 2 from 1, that means 1 is invoking this 2, so that means this 2 is also suspicious. Then it says right here, though, a group of methods can only be removed if no method outside the group invokes any method within it. So in this case, 0, which is outside of this group, invokes 1, and 3, which is outside of this group, invokes 2. So since they are being invoked by outside methods, they cannot be removed. So our output contains all of them, 0, 1, 2, and 3. Boom. Now let's take a look at example 2 where that's not the case and every node does not make it to the output. So in example 2, our input n equals 5, k equals 0, invocations equals a 2D array of integers, first array 1, 2, second array 0, 2, third array 0, 1, fourth array 3, 4. The output is an array of integers 3 and 4. So let's break this down by looking at the explanation. It says methods 0, 1, and 2 are suspicious and they are not directly invoked by any other method. We can remove them. So in this case, we have 0, 1, and 2, right? 0, k equals 0, so we know that 0 is suspicious. 0 invokes 1, so now 1 is suspicious, right? 0 doing his dirt. He needs a friend. He comes to 1. 1 feels peer pressure. 1 is like, okay, I'll go with you. Boom. So 1, now 0 and 1 are both suspicious. 1 comes to 2. He's like, yeah, 0 just told me about this plan he has. We're about to go do something suspicious. Do you want to come? 2 is like, yeah, he falling into the peer pressure too. So now 2 is suspicious as well. And not only is 1 pointing to 2, but 2 also has 0 coming at him as well, telling him the same thing. Like, yeah, me and 1, we got this plan. We're about to go do something suspicious. You want to go? 2 is like, yeah, I'll go. So now 0, 1, and 2 are all suspicious. But you got 3 and 4 over here. They didn't really fall into the peer pressure. They sat at their own table. They over here talking to each other. They're not suspicious. They're just having a good conversation. So they make it to the output 3 and 4. 0, 1, and 2, they probably got locked up or something. They wasn't able to make it to the output, so only 3 and 4 made it to the output. Explanation says methods 0, 1, and 2 are suspicious and they are not directly invoked by any other method. We can remove them. So boom, let's take a look at example 3. So in example 3, our input n equals 3, k equals 2, implications equals a 2D array of integers, first array 1, 2, second array 0, 1, last array 2, 0. The output is a blank array. So in this case, k is 2. So 2 is suspicious. 2 comes to 0. Now 0 is suspicious, right? He comes to 0 with his plan. 0 is like, that's a good plan, and now 0 is suspicious too. 0 goes to 1. 1 is like, it sounds like a good plan to me as well. So now 1 is suspicious, and then 1 goes back to 2. Is like, yeah, I'm with the plan. Now all 3 of these are with the suspicious plan, so we have to return a blank array. Boom. So now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution is not that difficult at all. Now, the first thing we're going to do is we're going to create an adjacency list. It's going to be a dictionary representing the invocation graph. The key is going to be the method, and the value is going to be the method it invokes. So we're going to declare a variable called dict, colon. It's going to be a dictionary, key integer, value integer. Come outside of that. Initialize it with the blank dictionary. Boom. Then we're going to build a graph from the list of invocations. So we're going to say for invocation in invocations. We're going to open up the brackets. We're going to say let A equal invocation square bracket 0. Come outside of that. We're going to say let B equal invocation square bracket 1. Come outside of that, we're going to say dict square bracket A, comma default, colon, square bracket blank array. Come outside of that, say dot append, open up the parentheses, pass in B. Now we need to track which methods have already been visited during the breadth first search. So we'll come underneath this, declare a variable called visited, colon, it's going to be an array of booleans, and we'll set that equal to an array, open up the parentheses, it's going to be repeating, colon, false, comma, count, colon, and boom. Now we need a queue that will be used to perform our breadth first search. So we'll come underneath this, declare a variable called queue, say colon, square bracket int, come outside of that, equals a blank array. Now we need a variable to store every method that is reachable from K, and these are the methods that are considered suspicious. So we'll declare a variable called container, colon, is going to be a set less than int greater than, initialize it, blank, sorry y'all, initialize it with a blank array. So come right here, put the equal sign, boom. Then we need to perform our breadth first search starting from method I. So we're going to create a helper function. I'm going to say func bfs, open up the parentheses, underscore I, colon, int, comma, underscore, add in container, colon, bool. Come outside of that is going to return a bool. We're going to open up the brackets. We're going to say q dot append, open up the parentheses, pass in I. Come underneath that, we're going to say while exclamation point q dot is empty. We're going to open up the bracket and we're going to visit the next method in the queue. So we're going to say let first equal q dot remove first, put the parentheses, come outside of that, boom. Then we're going to say visited square bracket first, come outside of that, we're going to set that equal to true, boom. And we're going to come underneath that, we're going to say if add in container, open up the brackets, and during the first BFS record every reachable suspicious method. So we'll say container dot insert, open up the parentheses first. Boom. Then we'll come right here. We'll say else if container dot contains, open up the parentheses, pass in first. Come outside of that, we'll open up the brackets. And if a non-suspicious component reaches a suspicious method, then suspicious method cannot be removed safely. So we'll just return false. Then we're going to explore all methods invoked by the current method. So we'll come underneath this, and we're going to say for neighbor in dig square bracket first. Come outside of that. Question mark, square bracket. Come outside of that. Open up the brackets. If we're going to see if we visited, or we're going to visit each unvisited neighbor. So we're going to say if exclamation point visited square bracket neighbor, then we are going to come outside of that, open up the brackets, and we're going to say q dot append, open up the parentheses, pass in neighbor. Now, even if the neighbor hasn't been visited yet, immediately detect if this component points into the suspicious component. So we'll come underneath this, and we'll say if parentheses, or excuse me, if exclamation point, add in container, comma, container dot contains, open up the parentheses, pass in neighbor. Then we'll open up the brackets and we'll return false. Boom. But we're not done yet, because we need to come down here. We're going to say return true. Boom. Now we need to create a variable that's going to store the methods that remain after removing all suspicious methods. So we'll come underneath this right here, and we'll declare a variable called final result, colon. It's going to be an array of integers. Come outside of that, blank array. Now, the first BFS, we're going to find every method reachable from K. So we'll come underneath this, and we're going to say BFS, open up the parentheses, K, comma, true. Boom. Then we're going to explore every remaining unvisited component. So we'll come underneath this, and we'll say for I in 0 dot dot n. We'll open up the brackets, and we'll say if exclamation point visited square bracket I, come outside of that, we'll open up the brackets, and if this component can reach a suspicious method, then no method can be removed. So we'll say if exclamation point BFS, open up the parentheses, I, comma, false. We'll come outside of that, we'll open up the brackets, and we're going to return every method. So we're going to say return array, open up the parentheses, 0 dot 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 n minus 1. Boom. Then we need to collect every method that is not suspicious. So we'll come underneath this, and we'll say for I in 0 dot dot less than n. We'll open up the brackets, and if exclamation point container dot contains, open up the parentheses I, come outside of that, open up the brackets, we'll say final result dot append, open up the parentheses I. Then we're going to return all remaining methods. So we'll come underneath this, and we are just going to say return final result, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. And we got an error, of course we do, with all this code. How could we not? So let's see where we went wrong. Let's see. Cannot convert via type A or any. So let me see. Invocation and invocations. Hold on, y'all. Let me see. So we got our dictionary. Then a default. Oh, that's because this is supposed to be an array of integers. So now let's run that again and see what that does. Okay, it did something. We're on to the next. Oh, this right here should be a colon. Let's see that right there. Boom. So now let's give that a run. Q should have another E. So let's give that a run. So I thought that was it, y'all. I thought that was it. Container. Okay, so let's put a T up there. And run that again. That's a lot of typos, y'all. My bad, my bad. Let's fix that and run it again. Let's see, it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, 0 milliseconds. Ooh, look at that, y'all. 1,134 milliseconds beats 100% of users. That's what I'm talking about, y'all. That's what I like to see. So, with that being said, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom part. And this is the rest of the code, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.